defining what is a matrix, and then we had different types of matrices. Next we have algebra of matrix. Algebra of matrices. What do you mean by algebra of matrices? That if we have two or more matrices, can we add the any two matrices? Or if at all we can add the two matrices, is any condition required? And similarly, can we multiply any two matrices? And then properties of addition and multiplication of matrices, all this will do. Now first of all, in this class I will take addition of matrix. Addition of matrices. Two or more. Say addition of two matrices. Let me start with. So remember, you cannot add any two matrices. Then what? The two or more matrices to be added, the condition is that they should be of the same order. What is the condition required? Condition required for two or more matrices to be added, they should be of the same order. And then how do you add? You add the corresponding element. Add the corresponding elements. By that I mean that if A is a matrix Aij of order m by n, and B is another matrix say Bij of the same order m by n, then A plus B will be obtained. They are already of the same order. Add the corresponding element, means Aij to be added to the Bij, and order of the resultant matrix will remain the same. Let us take an example. Say example 1. You have say A equal to a matrix 2, 3, 5, 4, 0, minus 1. What is the order of this matrix? How many rows it has and how many columns? 2 rows and 3 columns. So order of this matrix A is 2 by 3. Let me take another matrix B of the same order, say 1, 2, negative 4 and 2, minus 1, 5. This is also a matrix of order 2 by 3. So addition is applicable. So what will be the resultant matrix A plus B? Add the corresponding element, that is A11 to B11. So 2 plus 1 is 3, 3 plus 2 is 5, 5 plus minus 4 will make it 1, and likewise 4 plus 2 is 6, 0 minus 1 is minus 1, and minus 1 plus 5 will be 4. So this is the value of A plus B for two given matrix A and B. 3, 5, 1 are the elements of the first row, 6 minus 1, 4 are the elements of second row, and the order of the resultant matrix, that is A plus B, remains the same. And now let me define multiplication of a matrix by a scalar. Now next I define how do you multiply multiplication of a matrix by a scalar, that means a real number. How do you multiply a matrix by a scalar? Let's suppose A is a matrix of order m by n, Aij m by n, and K is any real number. Then what will be the matrix K times A? It will be Kij m by n. What do you mean by this? That the order of the new matrix Ka will remain the same, and K is a matrix obtained by multiplying each element of A by K. For example, if I call it example 2, if A is as usual 2, 3, 5, 4, 0, 1 as I took in the previous example, then what will be the value of 5 time matrix A? Multiply each element by 5, you get 10, 15, 25 the elements of first row, 20, 0, minus 5 the elements of second row, and order of the this new matrix remains the same 2 by 3 as of the given matrix A. Now the next definition is, given is a matrix A, then what is its additive inverse? Negative A. Negative A will be negative 1 times the matrix A. Later you will find that given is a matrix A, and just now I called additive inverse. If you add negative A to it, it will make it 0. And likewise, what do you mean by subtraction of matrices? A minus B. That you, to the given matrix A, you add minus B. Minus B means change the sign of each element of B and then add to A, that is A minus B. Now next, properties of addition of matrices. Properties of addition of matrices. The first property is commutative property, commutative law. Commutative property. What is commutative property? That if A and B are two matrices, of course A plus B should be defined. Then A plus B is same as B plus A. Order does not matter. Then associative property also holds good. Like in ordinary addition of ordinary real numbers. Associative property. What is associative property? That if A, B, C are three matrices, then A plus B added to C will be same as A added to B plus C. Then existence of additive identity. What is additive identity? Like in ordinary real numbers, set of real numbers, addition of real numbers, what do you mean by additive identity? 0 is the additive identity. In the sense that if A is any real number, then A plus 0 remains A, we call additive identity. Similarly, in case of matrices, what do you mean by additive identity? Given is a matrix A of any order, say m by n, then you consider a 0 matrix. 0 matrix of the same order m by n is the additive identity. Now, let me take an example. Suppose A is 2, 3, 5, 4, 0, minus 1. The order is 2 by 3. Consider a 0 matrix of the same order 0, 0, 0, 0, 0, 0. And obviously A plus this additive identity O matrix will make it 2 plus 0, 2, 3 plus 0, 3, and 5 plus 0, 5, 4, 0, minus 1. Similarly, so that remains equal to A. So a 0 matrix given is a matrix A, then a 0 matrix of the same order is defined as this additive identity. Next is additive inverse. Additive inverse. Given is a matrix A, then negative A is its additive inverse. And what do you mean by negative inverse? That given is a matrix A, then negative A added to it will make it 0. To verify this, it is something very simple to verify with the help of example. Finally, what is the distributive? The scalar multiplication distributes the addition of matrices. If k is a real number, then what is k times A plus B? It will be ka plus kb. We say the scalar multiplication distributes the addition. K of A plus B is ka plus kb.